Okay, we're going to create a new park feature. So another local park, Vista Homo Park, was not presented by a feature in any of the park's feature class. So here we're going to create it by tracking its outline against the base map image. The process is similar to the editing that we did previously. After creating the feature, we will add attribute values for it. We will also add the attribute values of the two park features we loaded here. And now we're going to start editing. Gonna close everything out and go back to edit tool. That we will go to here and use the bookmark. So go back to map and bookmark. So Vista Rosa Park, which is right here. That we have. Yep. The park itself doesn't take up the entire L shape, so lot just the portion show here, just around here. So we zoom into an area mode, or less matching the area around the park on the edit tab. So in the feature group, so go back to edit and feature group, we will say create a feature and click park symbol. And then by clicking the symbol, we have chosen the template. A template determines the properties that new features we create will have, and because the map has only one editable layer, parks is the only template available. And because all of the parks are symbolized the same way, the template has just one symbol. And then right click the parks layer in the create feature pane and click property. So I'm gonna right click here and say property, and the template property dialog box, unless we view and change the property of the template, we switch between general tools and attributes. So general is from here and we will go to attribute. So okay, we have an attribute and we can have a tools. So when we create a new feature in the layer, this drawing tool or construction tool as it is called to be selected by default polygon, and we can set a default add attributes such as value state park for new features. So attribute is right here. And we don't have to change any of the settings, so that's why we're going to click cancel, close the template property dialog box. And future templates are especially useful when we are creating many new features in a layer which varied symbology. For example, a points of interest layer might have different symbols and descriptive attributes for restaurants, museums, parks, and so on. A template allows us to choose the right symbol and a description for each new point as we added here. So we're going to create the park feature. We are ready to draw the boundary of Vista Hermosa Park. Again, the purposes do not require extremely high accuracy. We just want a boundary that approximately conforms to the yellow dotted outline here in the book that at the beginning here. So I think it was page 193. So if we decided to zoom in and work at large scale, we may be able to see and follow the fence line that encloses the park. So remember to use the editing shortcut keys. So, yep. Then we will move the pointer to the map. Cursor becomes a crosshair. So right now it's a crosshair. And we choose a starting point. Start point can be anywhere, although corners are usually good. For example, we might use the southeast, which is right here. Southeast, I'm gonna start here and go, 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 go. Double click there. So we start a point and can be anywhere, although corners are usually good. So that I started from the southeast corner of the soccer field. this is a soccer field? I don't know. Okay, maybe. Click once to start drawing the feature. A red vertex is added at the location where we click. So I have to finish first, then you can see if I select on it, you see the vertices. So I'm gonna delete that. Oh no. Okay, gonna. Oh, then I have to start. Right click on it. So I'm gonna cancel it. So I'm gonna have to restart. Go. There's a little walking trail. So you see the red one is the vertices. So I'm gonna use C pen. Okay. There. We want to start drawing the feature, the red vertices earlier we see added to the location where we just clicked. Move the mouse in the direction we want to. Don't drag, just move. As we move, the cursor remains connected to the vertex by a purple line. As long as we are moving in a straight line, we do not need to add a vertex. So now doesn't need to be perfect. When we come to a spot where we must change direction, we click add a second vertex. The new vertex is red and the last one added, and the first vertex turns green. Trace the boundary of the park the best we can, so following fence line, property lines, and sidewalks. If we add a bad vertex, we click the undo button on the quick accessor toolbar. When the polygon is completed, we click the finish button on the drawing toolbar, or simply double click. So the new feature still selected should resemble the figure. Again, the rest doesn't have to be perfect. So however, if we want to make changes, we will click vertices button in the tool gallery. So which is right here. And if we already dissatisfied with the feature, then we dissatisfy, you say delete, which I did. So I delete it, and if not, then I just say done, and I can save it. I like it, so I think it's already saved it for me. So then I save everything, and we will just close this create feature pane. Okay, this one I don't want it. Then I just say cancel. Right click on it. And now we're going to add attribute values. We have created Vista Hermosa Park feature, but we haven't given its attribute field. So on the Add tab in the selection group, so right here, and we will click this attribute button, confirm that the Vista Hermosa Park feature is still selected. Okay, so here is the attribute that we can add it on it. The attribute pane opens showing the attributes and values for this feature. Values in software managed fields, shape length and shape area are deemed and cannot be added. So the length and area values won't match those in the figure, but the object ID value may be different too. In the attribute pane, we will click the null value next to name, which is right here. And we will enter Vista Hermosa and click the null value for type. We will enter local park or recreation area. For acres, that I will leave it for now, and we have the shape and everything, so don't forget to save it and click yes. So we must still calculate the acreage for Vista Hermosa Park, and for the two park features we loaded here, which didn't have an acreage attribute, we could find these records by scrolling to the bottom of the park attribute table, but a more systematic way is to query for null values in the acreage field. Now we're going to close this out and right gonna save it first. Yes, click save and right click on it and go to attribute table, and I don't need to add anything. So now for the acreage, yes, and I'm gonna descending, ascending, then we have a 3 null value. So for the null value, we're going to calculate it. So we will select by attribute that in the select field attribute dialog box, we will build a query expression to find parks for acreage that is not given. So sometimes we could do, instead of select by attribute, I could do is make sure selection type is set to create new selection. You can rank it, you can sort it, and those null value will be at the top. We make sure selection type is set to create a new selection under expression. So select by attributes so that I have a parks and it's new selection expression add a class. So and then for the field we will drop down, we will have acres is equal to is null, so is null, then click add and click run. So acres is null, and confirm that invert where clause is unlocked. So I didn't check this, so make sure that this one is unchecked, and then confirm that the expression matches here, and now we run and we close this select layer by attribute pane. So in the table we will click the show selected records button. 3 records should be selected. So there was many ways to do it. You could just rank it and then you hit shift and select it. And so now in the table calculate the values for the acres field. So we will right click on it. So I'm gonna right click on it and calculate field and use the same expression, exclamation mark shape dot area at acres, exclamation mark again, and then click run. So now it's calculated for us already, and then go back here. So you see the data is here. So the result should be about 32 acres for Los Angeles State Historic Park and 36 acres for the Rio de Los Angeles State Recreation Area, and the 9 to 10. So yeah, it's 9.6 for me. To 10 acres for Vista Hermosa Park. The type values for Los Angeles and Rio de Los Angeles, the 2 parks we just loaded are non-standard in the table because they came from another data source. All other state parks have the value state or local park or forest. In the table, we're going to right click on the gray square next to the Vistas Hermosa record and click select unselect. 2 records are left selected. So I'm gonna where is the right here. So click here. There. So now this one is deselected, right? No, this one is highlighted. Click I have to clear this. No. Oh no. I'm gonna go back. So because it's sorted and I have to find them. Oh, that's an issue. But there is another way I'm gonna do is Los Angeles. So I'm gonna rank it, so it doesn't matter, and Los Angeles, yeah, 32, yeah, that's this one. I'm gonna select it, and then the other is Rio with R, okay, right here, 36 there. So I'm gonna hit Control, so this 2 selected, yeah, I'm got back. The 2 records are left selected. You could do many stuff, but I clear selection. So select clear. I clear everything, but I select it back and right click the type field and heading and click calculate field. So type and then calculate field. That will be weird. So that right click here and calculate field. In the expression, I will just type. Type state or local, state or local, park or forest. Okay, and then click run. Oh, so I have to put it's a string. So click run. There. So now the field changes. So the expression, we can compare the dialog box to the figure, and here we run, and value for the two select records are all updated. And confirm in the attribute table that the value for the two select records are updated. So I did. In the table, we clear the selection and show all records. So close everything out, clear selection, and go back to show everything. And now we're going to close the table and click everything. And we already saved everything. Okay, and now we will zoom to the parks and save the map. We will look at the work and save the project. We symbolize the parks layer to give it a solid green field color, and so I'm gonna right click on it, solid field, little apple. No. Little apple. Yeah, little apple, and and with the outline one width, so that's fine. Change the outline color too if we want, that's fine. We will use the bookmark, so go back to map and bookmark, and we will go to Become Playground. Become Playground, we updated boundary should be displayed already. So we will zoom to the Vista Hermosa Park bookmark. So the park should be displayed. So and Hermosa Become, and then we will zoom to the Become Hermosa Park there. So it's not a perfect drawer, but it's fine. As mentioned earlier, edits are written to the source data at the time we save them, although we are making a practice of saving maps. The edits have already been saved to the feature class. So now we will close everything and save the project and save everything. We're going to conduct the analysis. So before we conduct the analysis, I will do a little more about the field name. So because we use it, and I will not go over the geoprocessing tools. So for geoprocessing tools, I will talk about it once together. So the field data types, maybe I will talk about later. Then I can put everything together and talk about it. So, and the shortcut keys, I will for editing, I will do something. For the editing, it's just using base map and look at the patterns and be familiar with those items, and you just tracing things and draw things. So now we're going to move on to conduct the analysis. So now we come to the point of preparatory work, the analysis. The original feature class of puzzles was like an assembled 796,000 piece jigsaw puzzle covering the entire city, with each piece representing an individual owned property. So now we cut this down to about 29,000 puzzles, those that are vacant, and then to around 14,000, those that were adjacent. Now we will continue taking pieces away, moving unsuitable parcels until we are left with only those candidates that meet the criteria established in our table. So let's bring the table back again. On a vacant land puzzle, at least 1/4 acre in size that is within the Los Angeles city limits, within half a mile of the Los Angeles River, the closer the better. At least 1/4 miles from the nearest park in a neighborhood in which population density is at least 8,500 people per square mile. At least 22% of the population is under 18, and the median house income is 50,000 or less. So 50,000 or less, and preferably serving the most people within a quarter-mile radius. But how does this translate into a method and a workflow? How do we take these requirements and match them to appropriate geoprocessing tools is the right sequence. Planning a workflow means identifying the tasks, finding a suitable tool for each one, and understanding the inputs and outputs so we can order the operations in a efficient way. So that's very important. And then most of the tasks in the analysis, and this typically fall into just a few categories: distance problem, what is near what, and topological problem, what crosses, touches, or contains what, and attribute query problems, what has this or that value, and overlay problem, what areas are common to features in different layers. Each of these problems categories is associated with its own special set of tools. Before beginning an involved analysis, we may find it helpful to draw a rough plan or diagram. Any medium will do, paper and application whiteboard, as long as we prepare to make revisions as we go. So a typical working plan that we have could sketch out to look something like page 205, so that if you go to 205, that we can start a Los Angeles River, create approximately zone around the river buffer tool, and create approximately zones existing parks buffer tool, and then we can do subtract parks approximately zones from river proximity zone overlay erase tool, and assign demographic values from block groups to river proximity zone and overlay and identity tool, and favorable, not favorable, select areas with favorable demographic values attribute query, and we can select vacant parcels in areas if favorable demographics spatial location query. These are the recommended sites. And some census block populations within a distance of selected parcels overlay spatial join tool, and assign population totals for recommended sites for future consideration overlay identity tool. So now we look at the sketch here, and then the analysis, we can see that this plan represents only one of several possible approaches to the problem. The plan we are following here, I think, a reasonable and efficient. It uses a variety of important geoprocessing tools and has the visual benefit of seeing the analysis unfold as land areas are progressively stripped away from consideration. It is certainly possible, however, to reach the same or similar conclusion using different combinations of tools. So the analysis results depend on the state of the data in the project geodatabase. So if we have successfully completed all the exercises up now, that we have a good shape, then we don't need anything, and we will establish the proximity zones. So here we have two objectives. So the first one, we want to define the area of interest as half a mile zone around the river. Any parcels falling outside this zone will be excluded from consideration. And second, we want to draw quarter-mile zones around each park. Any parcel in the area of interest that align within these internal exclusion zones will be dropped. So we will use one simple operation buffer to significantly reduce the hunting grounds. So finally, we got to create a geodatabase. So we used the geodatabase that was created for us, and now we could just do it. Now. So, but here I will have to explain some of the tools along the way. But after this chapter, I will bring back for a lot of about the geoprocessing tools together to talk about it. But now we will continue. And then we will focus on all those geoprocessing tools. Okay. How excited! We're gonna create a geodatabase. So how do we do that? So for geodatabase, create a results geodatabase. Now we will generate outputs so that we did everything in our geodatabase. So of course, in the project file, so when we generate outputs, we need to store them somewhere. So we decide to keep the inputs data in one geodatabase and the output data in another geodatabase. So it is a matter of preference, but we think that it's easier to keep the project organized if inputs and outputs are separated. We may want to share the inputs data with someone else so that they can run the analysis independently. We may want to repeat the analysis with different parameters. So the more feature classes we add to a geodatabase, the harder it is to keep track of what they represent and what purpose they serve. So now we will insert a map to the project and name it lesson 6. So gonna right click here and new map. So I would just say lesson 6. I don't want to separate them, so I from now on, unless it's something it's really necessary, I will separate into A, B, C, D, E. But now I don't see I don't want to do one at a time. So I have too many maps. So okay, now we will close other maps by closing the associated tabs above the map. We can always get back to these maps by double-clicking them in the project pane. So in the maps group, so now in the project pane, we will expand database folder, and it should contain the Los Angeles River Parkside Project geodatabase. So which is right here in for database. That another way we can do is right click the database folder and click new file geodatabase. So new file data geodatabase, new right click on here, new file geodatabase. So new database connection, add a database. So here I would say just save it here, folders, and name the geodatabase analysis output and click save. So new file, new geodatabase. So new file geodatabase. By default, the dialog box should already be set to the project folder so that the new geodatabase will be created in this folder. We talked about geodatabase for a while, and we will name the geodatabase analysis output and click save. So I'm gonna analysis outputs, and then I'm gonna click save. Excuse me. Note that the new geodatabase has been added to the list of databases in the project pane, and we want to make analysis output the current workspace so that the output data is put here by default. So now we will set the current workspace. So when working with geoprocessing tools in ArcGIS Pro, it is convenient to set a default location to save the outputs, in this case new analysis outputs geodatabase. So it doesn't matter if it's ArcGIS Pro or ArcMap, so the default output location is known as the current workspace and can be set as an environment setting for the project. The Scratch workspace, so I'm gonna go back to analysis and go back to environment. So then I'm gonna reset to analysis output, analysis output, analysis output, analysis output, and then click OK. So now, so this default output location is known as the current workspace and can be set as an environment setting for the project. And the Scratch workspace is a second environment setting option for the output location of temporary data that we don't need to keep and maintain. By setting both the current workspace and a Scratch workspace, we save ourselves the step of browsing to a new output location every time we run a tool. On the Analysis tab in the Geoprocessing group, we click Environment button and click the Browse button next to the current workspace and browse to the new analysis outputs GeoDatabase and click OK. And we set the Scratch workspace to the same GeoDatabase. And compare to the figure, so compare here what I have, and then we're gonna click OK. So then we can move on. We will do buffers. So the analysis tools, that first one we do is for buffer. A buffer is a zone around map feature measured in distance units. We use the buffer tool to create a half-mile proximity zone around the Los Angeles River. For more information, we will go over a little bit. So I'm gonna run the tool and then talk about buffer, overlay, spatial join, and then we will continue. I know it's a lot of theories, and I will put them and summarize them at the end of this chapter. So on the analysis tab, so the tools gallery, we will click buffer. So then the geoprocessing pane opens the buffer. So buffer is right here. In the geoprocessing pane, we will click input drop down for Los Angeles River. Click OK. And then I have a Los Angeles River in output that I will see. Output. Now, because I choose Los Angeles River, it's from the river park side. And then the output, output will be analysis to GeoDatabase, which is perfect. I make sure that here. So, name this output Los Angeles River Buffer. I'm just delete this. Los Angeles River Buffer. Because we already set the analysis output GeoDatabase as the Scratch workplace, and the output will save to this location by default. So the distance text box, we're going to type 0.05. So linear unit, so it's going to be miles, and then 0.05. So click the drop down arrow for linear units and click mile, compare the setting. And here, when the tool is finished running, so then I expand here so you can see the Los Angeles River buffer is right here. So a message at the box of the geoprocessing pane notifies you that the buffer 2 completed successfully, and the new Los Angeles River buffer layer is added to the map, which is right here. And also note that the warning icon, so warning icon is right here, so we can see what's the warning, appears next to the output feature class next text box. Hovering over the icon notifies that the feature class exists, so that it will be overridden if we run the tool. So we're going to close the geoprocessing pane, confirm the presence of the new feature class by expanding the GeoDatabase folder in the project pane and looking in analysis output GeoDatabase. So the analysis tool shown here is by no means as a complete list, but they include several of the ones used most often in GIS. So it is hard and probably unnecessary to give an exact definition of what makes a tool an analysis tool. GIS practitioners solve problems of many different kinds, and most of these problems have facets that involve spatial relationships among geographic objects. How far A is from B, how many A's are close to B, which areas are common to A and B, how you get from A to B, and so on. Analysis tools quantify these relationships among features and their attributes. So query tools answer questions of the form: which features meet such and such condition, such and such condition, such and such condition. And select by attributes. Select features according to an attribute value or combination of values. Select by location. So we did select by attribute and select by location. Select features according to their spatial relationship feature in another layer, or sometimes the same layer. Spatial relationships include intersection, containment, adjacent, and distance. So I'm gonna bring this buffer tool here, and this is the buffer tool. So if you're not sure, you just click that and read through it, and then you learn a lot each time. So now we did for the select by layer and select by attribute, which is all right here. Map, select by layer, select by location, and you can select things and look at attributes. So proximity tool, the buffer tool creates a feature class. Let me go back here. So it creates a so buffer tool creates a feature class of polygons at a specified distance around input features. So it is often used to draw an exclusion zone. So exclusion zone around features. So A should be allowed within a mile of B. So no A's should be allowed within a mile of B to define an area of interest, we want to look for A's only within a mile of B. So the create Titian polygon tool creates a feature class of contiguous polygon around input point features. So each polygon shape is defined by proximately to the nearest point. Titian polygons can be used to define location areas, which areas are closer to A than to any other point, which are closer to B to any other point, and so on. So I'm gonna look at the create Titian polygon. So there. So okay. So this is the input and this is the output. So input points are parks within a river buffer. Each output polygon encloses the area that close to the point it contains than to any other point. So, and for the proximity tools, the near tool finds the nearest feature in one or more specified areas to each feature in the input layer. It writes the distance as a new attribute to the input near table, layer table. So let's look at near. So it's all here. So near is right here. As I mentioned that this tool finds the nearest feature in one or more specified layers to each feature in the input layer. It writes the distances as a new attribute to the input layer table. So the input features are vacant puzzle symbolized in red. The features to find are park screen. New attributes in the vacant puzzles table specify the nearest park to each vacant puzzle and its distances. So a table relates show the attributes of the nearest park to the selected puzzle. So overlay tool. Let's see overlay tool. Overlay tool set. Okay, so the basic purpose of overlay tool is to find common areas between different areas. Overlays answer questions about where A and B, each whether unique and important attributes overlap. In contrast to queries, which return selections of existing features, an overlay tool create new feature have attributes of both input layers. So the different overlay tools intersect. We have intersect, and then overview of the So intersect, yeah, this is intersect. So intersect union, so union is down here. And identity, which is right here, identity, erase, let's see, erase is right here, are the most common. So perform variations on the same basic process. They differ with respect to how much area from the input layers is included in the output feature classes. Common or only intersect. All areas, whether common or not, union. One input layers areas only identity, or one input layers area minus the common area erase. And then spatial join. Spatial join is right here. So for spatial join, it's a like select by location query with the added benefit of joining source layer attribute to target layer features. So spatial join that we could do is vacant puzzles red that with a quarter mile of the river are spatially joined to the river. In the output feature class, the river has the same geometry but new attributes. 400 vacant puzzles totaling 1,232 acres satisfy the quarter mile condition. So then we will perform the buffer We will perform the buffer parks to a quarter mile in next video.